going to be showcasing how to build AI and RAG, which is retrieval augmented generation pipelines using Dagger. And the reason why I'm doing this is because, as probably many of you, I try to like learn about this AI ecosystem, specifically because I had like a idea that I wanted to prototype. But then I found myself, finding a lot of like different and difficult approaches on how to do this, right? So you can either like, if you look for like RAG and AI, and I'm going to explain what RAG is in a minute, you're going to probably end up in one of these massive projects like LangChain, Baby AGI, AutoGPT, and the ecosystem is so big and so chaotic right now that you're gonna find like a very hard time understanding where to go and putting something together actually to do like a use case or to build an idea. So before jumping into what RAG is, it's funny that I started prototyping this because I came across this article that I'm going to share in general afterwards, which is basically this person, Ken Cancer, which is they are working for a company that they do a lot of AI. But the two things that I took from this article is that, first of all, that they don't believe LangChain is something that you probably need, and he gives a lot of reasons for that. I totally recommend you to read this article afterwards. And then he also believes that vector databases, which is something that I'm going to mention and RAG, they're not very useful as well. So this is interesting, right? But anyhow, I'm going to share this link afterwards. And the basically going into what RAG is. So this is how basically like a very typical AI use case works. You probably have a question or an input, right? And then you have like some source of information. And basically you give that to a model, and then you get an answer, right? Whenever you go to ChatGPT, or maybe you ask like an AI model, this is pretty much what's happening. The AI model has like a context, and then you ask a question, and then you get an answer of that. The problem is that, as you probably heard or seen, these models have a limit on the context that they can receive, right? You can like basically send, in many cases, like, I don't know, like the whole Wikipedia or like many books, because this model is not going to be able to like produce an answer based on that. So you're going to get an error saying, okay, the context is too big, I can't really process this. It also happens in ChatGPT after like a long session of chatting. Basically, the chat is going to be ended, and then you're going to get this error. And basically, the way to like overcome this limitation of models is basically to split basically your input into multiple chunks, and then basically have a way to only send the relevant chunk to the model about the question that you're going to be asking about, right? And as you can think, or you can imagine, the challenge of this thing is like of this approach is basically understanding which chunk you need to send to the model, right? Because relevancy might be something very subjective in terms of like what you want to ask a question for. So there's basically an approach to like solve this problem, which is you basically split your chunks, and then you generate what it's defined as an embedding, right? You're gonna see this like definition in a lot of like AI tools, where you basically send that chunk to like a model, right? And that model is gonna return you like a vector space of the meaningfulness of that document, which then you can run functional mathematical functions on top of that embedding, and then compute what is called like a similarity, like the cosine similarity on that embedding, which should give you like the most the closer basically chunks that basically correlate to your question, right? So you generate embeddings on these documents, then you generate embedding from the same model on your input, and then basically this cosine similarity function is going to basically should return you like the most relevant documents for your question, and then you can basically send that to the model, right? And on top of that, in order for you to not basically compute this every time, like the ecosystem came up with what is called like vector databases, where you can store all these in a database, and then you can query this in a faster way, right? So that you don't have to compute this every time, as I said before. Now, if you are trying to put all this together, right, to maybe like a very basic demo, imagine that you want to say, oh, I have some documents that I want to like run some like AI questions about, and then I want to do some RAG. you're probably gonna find yourself with a lot of like code to write in Python, especially in LangChain, which has like a specific way of like typing, building these pipelines, which is a bit complex. And I was trying to see if there was a way to simplify this with Dagger. So the first thing that I found, which is nice, there's one project that is called Llama Index, which actually gives you like a RAG CLI. So they basically like bundle all these like Python code, a lot of the things that I shown before, like even the embedding and the vector database and all that, into like a very simple CLI. Here it is telling you how to set up the environment and how to install all these things. That given a folder in your machine with multiple files, right? You can have like maybe PDF files or like even images. You could then spin up this RAG process, generate the embeddings, and basically ask questions about your data, right? And I'm going to show you in a minute about what that is. So what I did, right, of course, because I wanted to like simplify this and package it so anyone could use it, and maybe I could reuse it. I'm going to see that in a minute. I basically created a Dagger function that is called RAG. And then in this particular case, this CLI is using OpenAI as a model, but you can use Ollama or any other models that are out there. It is not only limited to OpenAI. And then, as you can see, I specify a source directory, this is going to be the directory where my files are going to live. And then you can specify a question. What I do here is basically I set up my Dagger pipeline container, right? I set up the secret for this to work. I mount the files on the target container, and then I call basically the Llama CLI to basically ask questions about the files. So I can show you in my local machine, I have like a source directory, and inside this source directory, I have two files. This file is a PDF of the Nix paper, right? So you can see here, it's basically the Nix paper that explains what Nix is about, properties of the system, etc. And the other file is an image that is called sample PNG, right? And it says the quick brown fox jumps over the lazy dog. So now what I'm going to do is I'm going to use that Llama CLI application to actually run a RAG pipeline with those files. And the good thing is that this is like wrapped in a Dagger function. So I can just do a Dagger call RAG, and then you can say OpenAI API key. This is going to be OpenAI API key. My env variable is already set with this. And then you can say source is going to be my source folder. And then question, let's ask who are the Nix paper authors. So let's see how this goes. This is going to initialize my Dagger pipeline. A lot of these things are already cached because I already ran it before. As you can see here, it's generating the embeddings, loading the files and all that. And this is sending the data to OpenAI, right? Because I'm using the OpenAI model. So it's sending the data to OpenAI, so it generates the embeddings. And then you can see basically the author of the paper here. You can also ask something else like, what are the Nix ingredients? And basically the paper mentions about some ingredients that a Nix has. Again, same thing, generating embeddings. By the way, I tried to use caching for this part, but looks like this Llama index has some issues with that. As you can see here, I commented the mounted cache. So the Nix ingredients consists of the Nix store for storing isolated installations of components, user environments, etc., etc. So as you can see, it's working. And not only that, but I could also ask one last demo of this part is what was the PNG about? Who jumps over the lazy dog? I don't know if he's going to take that because it's not a question, but let's see. So it should also read the text from the PNG, and it should also return the answer. So, okay, the quick brown fox. So as you can see, it's basically like reading from like multiple files in my source and then doing all this. So then going back to basically the reason for this call, then I had a better idea. I wanted to do like a broad pipeline and like a more complex use case. Is imagine that I could get like a YouTube video, right? Then I could extract the audio file of that video, and then I could get the text basically of that audio file, and then I would like to send the text, which I have it like a file, to my RAG container or pipeline that I just built, right? So this is like a very nice idea. Like many people could have like crazy ideas on how to build things on top of RAG. But if I would want to build this in LangChain, which is like the main basically framework to build this, that would involve like a lot of moving pieces to actually like connect different parts and what they call like parsers and retrievers. And it becomes like quite messy. And you need to have experience in Python and on this ecosystem. But for anyone to prototype something like this, it should be way more approachable, right? So what I did with Dagger, which I actually found very cool, going back to my original RAG pipeline, I basically created a new function that is called YouTube chat, right? Where what I do is like, first I use this very shady CLI that you probably seen or heard, which is on GitHub, which is YouTube download, that is gonna allow me to download the MP3 of the YouTube video, right? Then after that, I use another CLI that is called Whisper, which is the OpenAI Whisper that allows translating audio to like text using a model. This doesn't incur any like OpenAI API charges or anything. Everything runs locally and offline here. You can run all that locally. And then this gives me like an TXT file of that audio. And then I'm going to send that to my previous pipeline, the one that I did with RAG, and basically ask a question about the YouTube video, right? So in this case, and to wrap up this presentation, I'm going to open this YouTube video that I have here, which coincidentally is basically Kyle showing Dagger in Python. So this video basically shows Kyle. I think this was like a previous community call where he like basically creates a new SDK in Python, and then he creates like a new web function here to like serve some files on Nginx or something on about that. So now that I have this here, I can tell my my pipeline basically YouTube chat, and I have the auto-completion here. So YouTube chat, I have my OpenAPI key, I send the same YouTube video, and then I can say, okay, what is the video about? What is the video about? This is going to download the video, do all that conversion, audio processing, text extraction, and then it's going to call my RAG pipeline. And it says the video is about getting started with the Dagger Python SDK, demonstrating how to use the SDK to create containers, manipulate directories, etc., etc. So then I can ask something else like, what are the functions mentioned in the video? And this is gonna probably say a container echo, probably, hopefully, if it doesn't hallucinate. Container echo, which is the one that you saw in the video here, and then it says web because Kyle does not mention this grep function in the video. It only goes through this one, and then he creates a new function that is called web, right? And then if I ask one last question, what is the name of the speaker in the video? Let's see what it says. It says the name of the speaker in the video is not provided in the context information. And this is correct because Kyle never presents himself on that video, which is great. I would have thought that he may have hallucinated the AI. In any case, I mean, and to wrap up this presentation, the idea behind this is that you can very easily materialize an idea that you want to build with AI and RAG without basically diving into all the Python madness, I don't know, like frameworks or things to basically put a use case in place. You can just like use the building blocks that basically the CLIs out there or maybe Dagger gives you and actually put all these together. The last thing, which is great, is that all basically the current AI ecosystem is very tied to Python, right? So if you have a tool that could actually produce like an input for AI that is written on a different language, it might become a bit cumbersome to actually connect all the pieces together because you're going to have to basically fall back to scripts or maybe shelling into some other things that are complicated to test or to share or to basically package. And of course, as you probably know, Dagger actually helps a lot with this. So yeah, I just wanted to share like some crazy ideas on how to prototype things using AI, and happy to answer any questions.
Wow, that was amazing.